All right, so in this video, we're going to continue what we started in the last video. The last video, we started talking about how to solve an equation that has an exponential expression or a logarithm expression. But in the last video, we focused on what I call just simple equations, where it was just like 10 to the x equals 5, or just something like that. Just nice and simple. There's an exponential expression and nothing else. Or something like log of x equals 2. Nice and simple, just a logarithm expression and nothing else. In this video, what we're going to do is we're going to take that to the next step. So we're going to, again, be solving equations that have exponentials or logarithms in it, but there's going to be other things there that we'll have to work around as well. So with that said, let's go ahead and get started. Only one learning objective for this, and that is simply to be able to solve those equations. But realize that the equations they're simply going to contain an exponential or a logarithm, but they're probably going to have other things as well. Okay, so being able to work with that. Obviously, to work with something that has these two things and other things also, you first want to make sure that you can work with these two things. So if you haven't watched the previous video where we talked about how to solve an exponential expression or how to solve a logarithm expression, you should go back and watch that other video before you watch this. Otherwise, this one will probably not make a whole lot of sense to you. But if you've watched the last video, then you're ready for this, and you're ready, and let's get going. So in the last video, we took an equation, something like this, and we talked about how to get the x out of the exponent so that we can figure out what x is. So this was solving an exponential equation. In solving an exponential equation, to get the x out of the exponent, what we talked about in the last video is that the logarithm is what achieves that, because the exponential and the logarithm are inverses. Now, in the last video, I explained two different ways to think about this. And it doesn't matter which way you think about it, they both have the same effect. So for this video, I'm just going to simply say use the logarithm. And you use it whichever way you want it. If you preferred the idea of taking the log of both sides, then when I say use the logarithm, that's what you're going to do. If you preferred the idea of rewriting as a logarithm, then when I say use the logarithm, that's what you're going to do. But it's 100% up to you which way you think of it. Either way, you're going to use a logarithm. And when you do that, the result is that you're going to end up with whatever was in the exponent all by itself on one side of the equation. Now, it doesn't matter which side of the equation it's on. Remember, these two equations mean the same thing. So it doesn't matter which side you put it on, but you're going to end up with that variable on one side of the equation. The other thing you're going to end up with is a logarithm expression. And it's always going to be the case, if you've done this correctly, that the base that we had here and the base that you have in your logarithm, those should always match. If they don't match, then something has gone wrong, okay? So that should always happen. And then you'll have whatever number was on this side inside of your logarithm, okay? So again, it doesn't matter which way you think of it. You can think of it as taking the log of both sides. You can think of it as rewriting it as a logarithm equation. Either way, what you end up with in this particular case, if you start with e to the x equals 5, what you're going to type into your calculator is the natural log of 5 to figure out the value of x. And then from there, we said, hey, just grab your calculator, type in what you need to type in, and there's your answer. So in this particular case, if I round off, I'm going to round it off to the hundredths place right here. So it's going to give me approximately 1.61 for my value of x. All right, and so that's the idea that we talked about in the last video. And again, you can think about this either way, whichever way you want to think about it in that middle step, that's entirely up to you. All right, so that's what we did in the last video with exponentials. We also did something similar with log equations. And in the last video, we started with equations that had some kind of log that had an x in it equal to some random number. And then we had to solve this. So it was the exact same process in reverse. You used an exponential to get the x out of the logarithm. Because remember, this isn't like log times x. This isn't log times x. This is, we are taking the log of x. Log is its own kind of function. Just like multiplication is its own kind of operation and division is its own kind of operation. Log is its own kind of operation. And so we're taking the log of x here is what we're doing. And what undoes a logarithm is an exponential. So just like we talked about here, if you think of this as I'm going to take the exponential of both sides, or I'm going to exponentiate both sides, if that's the way you think of it, that's fine. In this video, I'm just going to simply say use the exponential, right? If the way that you think of it is I'm going to rewrite it as an exponential, that's also fine. But in the video, I'm just going to say use the exponential in this particular video. And again, if you haven't watched the last video to see what the difference is between those two things, then make sure you go back and watch that last video. But whichever way you do it, you need to recognize what the base is here, because the base of this logarithm is going to be the base of your exponential expression. And one of the things that we know from our previous discussion on logarithms is anytime they don't write the base in, we always assume the base to be a 10. And so what I'm going to do then is use the exponential. And just like before, my bases should match. If they don't match, I've done something wrong. I'm going to use the exponential, and I'm going to end up with whatever that answer was over here as my exponent. And I'm going to end up with whatever it was that was inside of the logarithm all by itself. And again, however you think of that, if you think of that as exponentiating both sides, if you think of that as rewriting as an exponential, however you think of that, eventually this is what you're going to end up with. And now, again, I just grab my calculator and I figure out what this exponential expression is equal to. In this case, probably most of us know that 10 squared is 100, but that becomes my last step and I'm done. So as we talked about in the last video, the basic process is the same for both. We're going to use the inverse operator to get the x by itself, or maybe I should say to get whatever was in the expression by itself. And then we'll just simplify from there. All right, now what's going to happen though is in this video, there's going to be extra pieces. So this might not just be an x, this might be an x plus 1. In which case, when you use the inverse, the x isn't by itself yet, right? The x isn't by itself yet. So there's going to be more things that I'll need to do. Or this might not be just a logarithm. It might be like 2 times the logarithm. So first, you're going to have to get the logarithm by itself before you can do the rest of the stuff. And that's what we're going to see in this particular video. So to do that, I've written up two processes. So right now, you may want to pause the video and get those two processes written in your notes. All right, so hopefully you've got these written in your notes. Again, if you don't have them in your notes yet, probably pause the video so that you can get these captured in your notes. But what I want you to see is that it's functionally the exact same process no matter which of the type of equation you're working with. The first thing you're going to do is get the expression that has the x in it all by itself. Now, I will say for most students, when they're first learning this process, that first step is the hardest step. All right, so we'll talk a little bit about that in a couple examples here. But the first thing is you're going to get whatever expression has the x in it. So whether it's the exponential or whether it's a logarithm, you're going to get that thing all by itself. Then, once you get it all by itself, you'll use the inverse. In fact, you could probably just write this as one procedure, where right here you just say, use the inverse operator, okay? The inverse of an exponential is a logarithm. The inverse of a logarithm is an exponential. So we're going to use the inverse to get rid of the thing that has the x inside of it. And then, if we need to, we'll finish solving the equation for x. And like always, any good mathematician always checks their answer. That might be particularly important when you're working with logarithms. Because remember, logarithms do not have a domain of all real numbers. In other words, when I'm solving a logarithm equation, it's possible that I'll get an answer here like -5. Well, -5 is something you're not allowed to plug into a logarithm. So it's important that you check your answer to make sure that it actually works. So with exponentials, checking your answer perhaps a little bit less important, because with exponentials, the domain is all real number. So whatever number you come up with, you can plug it back in and it can work. Checking your answer really is just looking to make sure you didn't make an arithmetic mistake. That's all you're doing when you're solving an exponential, checking to make sure you didn't make a mistake. But when you're checking your answer with a logarithm, you're not only looking for mistakes, you're also looking for extraneous solutions. And it's the extraneous solutions that are the bigger issue, because even if you do all of your algebra 100% correct, there's no mistakes. Because logarithms do not have a domain of all real numbers, it is possible that you'll end up with an answer that doesn't actually work. All right, so this is our process. And again, hopefully you've got this captured in your notes. If you don't, pause the video again, get that captured, make sure you've got those ready to go. Now we're just going to work through some examples. All right, so here is our first example. For our first example, we are going to solve an exponential equation. And we're going to start off without getting too crazy yet. We're going to say I've got 3 to the 2x plus 1 power equals 17. 3 to the 2x plus 1 power equals 17. Okay, now our process says the first thing we want to do is get the exponential all by itself. Well, in this case, the exponential is this thing right here. It's something that has a base and it has an exponent. That's my exponential, the thing that has a base and an exponent. And right now, this exponential is all by itself. There's nothing I need to do. And remember, when we say all by itself, what we mean is there's nothing else on that side of the equal sign. So there's an equal sign and there's other stuff on the other side. But on the left-hand side of my equal sign, all I have is the exponential, the thing with a base and an exponent. So my first step, isolate the exponential expression or get the exponential all by itself. That step is done. So now I'm going to use the logarithm. And again, it doesn't matter how you think about this. You should use the logarithm to get this exponent all by itself. But now the exponent is not going to just be an x. There's going to be other stuff with it. So however you think about that, do that right now. Okay, so hopefully when you did that, you ended up with a log of base 3 of 17 equal to 2x plus 1. And again, depending on how you think of that, you might have the two sides of the equal sign reversed. You might have the 2x plus 1 over here on this side and the log on this side, and that doesn't matter. But you should have a log base 3 of 17. We should both have that no matter which way you do it. And you should have a 2x plus 1 no matter which way you do it. Okay, so now I grab my calculator. I need to figure out what the log base 3 of 17 is. And remember, I don't have a button for log base 3 of 17. So this is, again, something I talked about in the last video. So if you haven't watched that last video yet, I'm going to plug it again. Make sure you go back and watch that last video. The way that we typed this in was using the common log. And we said we would do the common log of the big number, so common log of 17. And then we would divide that answer by the common log of the base. If you think of it as a fraction, what I said was the base always is in the bottom, right? If this is a fraction, then the log of 17 would be the top, the log of 3 would be the bottom. The base always goes in the bottom of the fraction. And so there is my expression, and this happens to be what the log base 3 of 17 is, all right? So I'm going to go ahead and write down on my paper a rounded off version. Actually, I'm not even going to round off. I'm going to do what's called truncating, where I just ignore the rest of the decimal, okay? But on my calculator, I'm not going to do that. Remember, on my calculator, I don't want to round off until I get to the actual final answer. So I'm going to be using this great big long decimal. I'm just going to save myself time by not writing it on my paper. And if you've forgotten how to do that, then I'll show you that as we go along here. But now I'm on my third step. The third step is finish isolating x, finish getting x by itself. And so in this case, it really becomes just like a normal regular algebra problem that we would have done back in Algebra 1 class. I'm going to start by getting rid of this 1 and subtract 1 from both sides. So on my calculator, to subtract 1 from this, I'm going to use the fact that it has the answer feature built into it. In other words, if I use the arrow buttons, I can highlight that number and push enter, and it types that in for me. So I don't have to worry about typing all those numbers in, and I don't have to worry about rounding off and getting a wrong answer. I'm using the very decimal that the calculator found, and now I'm just typing in -1. And so there is the first part. Now on my paper, I'm a little lazy, so I'm not writing all those decimals on my paper, but on my calculator, I've got all the decimals. So now when I need to get rid of this 2 by dividing both sides by 2, I can do that. So again, I'm just going to take this answer by highlighting it with the arrow button and then pushing enter. And now I'm going to type in divided by 2. And that gives me my answer. Now, it doesn't matter if you're not using this type of a calculator, it doesn't matter what kind of calculator you're using. Pretty much every calculator has the ability to use a previous answer in the arithmetic process. Some of them have an answer button. Actually, this one has an answer button also. That could have been another option. I could have typed in second answer, and that would have done the same thing. It would take that answer and let me use that. So that could be an option. With some calculators, you can just simply type in, like, right here, if I just simply took the nothing on the line and just hit -1, it automatically plugs in the answer. Okay, so there's lots of ways, depending on the calculator that you're working with, that you can do that. This particular calculator actually does it all 3 ways. Okay, but there we go. Now we have an answer. And since this is our final answer, now it's okay to round it off. And so there I've rounded it off in this case to 3 decimal places, to the thousandths place. But there we go. That would be an example of getting an exponential equation solved for x. All right, we do want to go back and plug that in. So if I wanted to plug that in, that's not too hard to do. I just type in 3 to the 2 times, and then again, I need that answer that I got back up here. So I'm just using my arrow button to highlight that number, push enter. It types the whole thing in for me, +1. Okay, and sure enough, 17 is exactly what we end up with. So I get the right answer. All right, so that's the process using an exponential. Let's take a look at one that has a logarithm equation. So example number 2, right? So for this, we're going to solve 2 times the log of 3x plus 1 equals 19. 2 times the log of 3x plus 1 equals 19. Okay, I'm sorry, I did copy that down wrong. My apologies. It's not log, it's log base 5. That's a 5. Log base 5 of 3x plus 1 equals 19. There we go. There we go. All right. Now, this is one that's going to end up with a really, really big answer when we're done, but that's okay. We'll deal with that. So if you think you feel comfortable with this, maybe pause the video and try at least the first step, and then resume the video and see if your first step matches my first step. And then you can pause the video and try the second step, and then resume the video to check your second step with mine. But give that a try if you would. All right, so our first step is to isolate the logarithm. And remember, this is part of the logarithm. This is what we're taking the log of. So when I say isolate the logarithm, this whole thing is my logarithm. This is what I'm trying to get by itself. Okay, so there's my log. It has something inside of it that I'm taking the log of, but that whole thing together, that's what I'm trying to isolate. That's what I'm trying to get by itself. And when I say isolate or get by itself, I mean on that side of the equal sign, on this side of the equal sign, all I want is that log and nothing else. So what do I have that's extra? It's this 2. And the 2 is multiplying, right? Anytime we don't write a symbol in between, that means multiply. So the 2 is multiplying. And what cancels out multiplies? divides. So if I want to get rid of this 2, I'm going to divide both sides by 2. Now, this stuff is in the logarithm. So it's like the logarithm is protecting it from this 2 that's out here that I'm dividing by. So when I divide the left-hand side by 2, these 2's cancel, and nothing happens to my log except now it's by itself. Okay, because again, the 3x plus 1 is inside the log. It's part of the log. So this is my logarithm expression, and it is now by itself. On the other side, if I do 19 divided by 2, I'm going to get 9.5. Whoops. If I type it into my calculator correctly, now I get 9.5. So over here, 9.5. Okay, so now I've gotten the logarithm by itself. The next thing is to use the inverse. So in this case, we're using an exponential to isolate the stuff that's inside of the logarithm. So again, I'm going to ask you, pause the video and give that a try. Once you've done that, resume the video to see if your answer matches mine. All right, so when you did that, you should have, in this case, used an exponent that has a base of 5. So again, it doesn't matter if you exponentiate both sides or if you just rewrite it as an exponent. In either case, you're going to have a base of 5. After you simplify it, you're going to have a base of 5. And you're going to have this 9.5 ends up in the exponent after you simplify. And this 3x plus 1 is going to be off to the other side by itself. And again, it doesn't matter which side those two things are on, but that's what you should end up with after you've done the inverse step. Okay? Now we're ready to find our answer. So this 5 to the 9.5 power, I'm going to type that into my calculator, 5 to the 9.5 power. I get a big number, but that's okay. We can work with big numbers, just like we can work with decimals. These things are all part of the number system still. The only difference is with the decimal, on my paper, I can round off a little bit. With these big numbers, it's hard to round off because, I mean, I still need all these digits, right? So that's a little bit harder to do. All right, now I need to finish solving for x. So to get this x by itself, I'm going to need to get rid of this 1. So if I take that answer and do -1, okay, now I've got this. And the next thing I'll need to do is divide by 3. And then, of course, these 3's will cancel. That leaves me with the x all by itself on the right-hand side. On the left-hand side, if I take that answer and I divide it by 3, I'm going to end up with this number here. Again, pretty big number. That's okay. I'm going to round this one off to 0.1, if that's all right with you. Okay. Oops, you couldn't quite see. There. So I took that number, I rounded it off to 0.1. So there we go. And that's the end of step 3. I still want to double check my answer. Of course, with this particular one, double checking is particularly important because it's possible that I end up with a number that doesn't work inside of the logarithm. It's possible I end up with a number that's outside of the domain. In this case, I don't think I did, but it's possible that that can happen. So my original problem was 2 times the log base 5. So I have 2 times. Now, log base 5, how am I going to type that in? I'm going to type in the common log of this stuff. So 3 times my answer plus 1. Parenthesis, close that parenthesis off. If I don't close that parenthesis, I'm going to end up with the wrong answer. And then to get the base 5, I'm going to do divided by the common log of 5. And if I type in my end, I should get 19, fingers crossed. Yes, we got 19. So that checked, it worked, we're good to go. All right, so there's one example of both an exponential and a logarithm. Now, I do want to do one more example. I want to go back to an exponential for our final example, and then this will be it for this particular video. I know the video is starting to get long at this point, but I do want to make sure that we talk about one important thing when it comes to exponentials. All right, so let's say I've got something like 3. I did 3 last time, didn't I? Let's not do 3. Let's make that 3 into an 8. Okay, so let's say I've got an 8. And that 8 is raised to the x power. That 8 is also being multiplied by 3, and that 8 is being added to a 5. Let's say equal to 17. Let's say that. Okay, now here is the thing I talked about when I wrote down the procedure at the beginning. This part is where students often make their mistakes because they see these parentheses and they feel like, I think I need to simplify something before I do anything. All right. So, but remember, in the order of operations, when you see a grouping symbol like parentheses in order of operations, what Aunt Sally means when she says do grouping symbols first, she means simplify anything inside of the grouping symbol that can be simplified. Well, that's just an 8, right? Inside of the grouping symbol, there's nothing there except for an 8. So there's nothing that simplifies inside of my grouping symbol. Now, outside of my grouping symbol, I have 3 things. I have a multiply, I have an exponent, and I have a plus. In the order of operations, what comes first? Exponents come first, right? Exponents come before multiplies and exponents come before addition. So that means this exponential expression does not include the 3 because exponents happen before multiplies. And it does not include the plus 5 because exponents happen before the plus. And so this is the thing that I'm trying to get by itself in step number 1. Now, think about if this was just if this whole thing was my x, if that fluorescent box was my x, and I wanted to get the x by itself, I would subtract 5 and then I'd divide by 3. All right. In this case, that's the same process I'm going to do, but I'm getting the entire exponential expression by itself. So I'm going to subtract 5 from both sides of my equation. When I do that, these 5s will cancel. The exponential expression is protected from that, right? These cancel out before they get to there. So I still have 3 times 8 to the x. On this side, 17 minus 5 is equal to 12, okay? So again, this is what I'm trying to get by itself. That's what I'm trying to isolate. If I want to get that by itself, currently it has a 3. The only way to get rid of that 3 is to divide both sides by 3. I've got to divide both sides by 3. So these 3's are going to cancel before it ever impacts the 8. The 8's protected. So those 3's cancel. That's going to leave me with the 8x on this side. And then 12 divided by 3 is equal to 4. Right? And so that's the process of isolating my exponential. And as I said before, it's that where students are most likely to make mistakes. And you might be able to envision the kinds of mistakes that people might make. Like some people would try to multiply these together, right? That would be a mistake. That would be bad. Or some people, when they divide here, they would divide this number also. Okay, that would be bad. So this is our basic process. I'm trying to get this fluorescent box by itself. And as I cancel things off, they cancel before they impact the fluorescent box. And so that keeps it protected. It doesn't change. It allows it to stay the same as we go through the process. And now at this point, now it's the same as what we did in the last video. It's the same as what we did in example number 1. We need to isolate the x by using the inverse operator. So you should be able to finish this from here on your own. You're going to use, in this case, the logarithm. You're going to want your logarithm to be a base x. So whether you think of it as taking the log of both sides or rewriting it as a logarithm, it doesn't matter which way you think about it. Either way, after you've simplified, you're going to have something that looks like this. It doesn't matter which side the x is on, which side the logarithm is on, you're going to get the same thing both. And again, if you're not sure how I'm getting these equations here on this particular step, when I get to step 2 here, if you're not sure how I'm getting these equations, go back and rewatch the last video where I explain how exactly it is that you go from here to here. Okay, so there's our step 1. Here's our step 2. Now I'm just going to type this into my calculator to get step 3. This is another thing, if you're not sure how I'm typing this into my calculator or why I'm typing it the way I'm typing it, if you're not sure where I'm getting that from, go back and watch the last video. Make sure you're comfortable with that. But it looks like for this one, we're going to end up with x equals 0.6 repeating. And there's my answer. Okay. Now, to wrap up, I would check my answer to make sure that it works. And what was it? +5. And it does work. All right. So that is it for this video. I appreciate your watching. Hopefully you feel comfortable with both of those procedures. At this time, you should go on and work through the homework problems associated with this video. And in the next video, we'll wrap up our logarithm discussion by talking about how we're going to use functions in like real world scenarios. All right. So thanks for watching. Have a good one.